Chapter 9, Calculation of Oral Liquid Doses. At the end of this chapter, you should be able to interpret orders and calculate the volume of oral liquid medication necessary to administer ordered doses using either ratio and proportion or dimensional analysis, and discuss the process of reconstitution of powders into oral liquid medications. We will go over the keywords throughout the chapter. Administration of oral liquid medications. Liquid medications may be administered with oral syringes that are available in 1 ml, 3 ml, 5 ml, 6 ml, and 10 ml sizes. Medication cups, droppers that are available in different measurements, frequently tailored by the manufacturer for a specific drug. Dose spoons, pacifiers that hold a measured amount of medication, or household devices such as teaspoons and tablespoons, which are not recommended. The choice of administration device depends on the volume of medication to be administered and the availability of supplies. Teaspoons and tablespoons are sometimes used for doses in the home setting when calibrated devices are not available. The use of kitchen utensils is discouraged because of inaccuracy. And just a tech note, when a medication dropper is provided by the manufacturer, it should be used for administration of that particular drug only. When measuring oral liquid medications using a medicine cup, read the line of the medication to the meniscus, which is at eye level. The meniscus is the curved line that develops when a medication is poured into a container and should be measured at the lowest point. For medications that Just a tech note, when a medication dropper is provided by the manufacturer, it should be used for administration of that particular medication. And when measuring oral liquid medications using a medicine cup, read the line of the medication to the meniscus at eye level. The meniscus is the curved line that develops when a liquid is poured into a container and should be measured at the lowest point. For medications that must be more accurately measured, an oral syringe should be used. With the 1 ml and 3 ml oral syringes, the dose is measured using 0.1 ml increments. With the 5 ml, 6 ml, and 10 ml oral syringes, the calibrations are in 0.2 ml increments. Liquid drug preparations are labeled with the weight of the drug per unit of volume. Most are expressed in the metric units of milligrams per milliliter. Occasionally, you will see per teaspoon or per tablespoon on a manufacturer's label. Even more rare is the use of the apothecary system. Most labels using grains will include the metric measurement as well. Remember, the dose is the amount of medication to be administered at a specific time, whereas the dosage is the total amount of medication that will be dispensed and administered over a particular length of time. A physician may order amoxicillin 500 milligrams TID for 7 days, or a patient who requests a liquid dosage form. If the medication on hand is amoxicillin 250 milligrams, which is the weight, per 5 ml, which is the volume, the known amounts can be placed into a ratio and proportion or a DA equation to determine the correct dose of medication. The total dosage to dispense is found by multiplying the amount for one dose by the number of doses per day for 7 days, which is discussed in chapter 11 as well. So let's do examples 9.1.
Okay, so example 9.1, a physician orders amoxicillin oral suspension, 500 milligrams TID for 7 days. The medication available is amoxicillin 250 milligrams per 5 ml. How many ml are needed for one dose? So one dose meaning every time they take it, not for the entire 7 days. So we have the stock strength here. 250 milligrams over 5 ml. I'm gonna put that in one side of a proportion, which means I need milligrams here and milliliters here. Our question is asking us how many ml, so that's gonna be our X. And the physician wants us to give them 500 milligrams. So we're gonna cross multiply and divide. So we have 250 times X, and then we have 500 times 5. So what we want to do first is find the how much 500 times 5 is, which is 2,500. And then we want to carry this with us, and then we want to get rid of that 250 because we want to have X alone. So I'm going to divide that here. So now I just have X. Then I have to do it to this side as well. So 2,500 divided by 250 gives me that X is equal to 10 ml. So that's how much they need per dose. Okay, so 9.2, a physician orders Septin oral suspension 200 milligrams every 12 hours for 10 days. The medication on hand is cefuroximine 125 milligrams per 5 ml. What volume should be given per dose? So just like the other one, I'm going to take the strength of the medication, 125 milligrams over 5 ml. Then I know I need milligrams here and milliliters here. They're looking for volume, so that's going to be milliliters, so that's my X. And we need 200 milligrams. So we'll do 125X is equal to 200 times 5. So first we need to take care of that 200 times 5. That is 1,000. And we have 125X is equal to 1,000. Now we want to get X alone. So to do that, we need to divide each side by 125. So here we get 100, get rid of that 125 and we just have X. And then we need to divide 1,000 by 125 as well. And that is going to give us 8 ml. So they need 8 ml per dose.
Examples 9.3 and 9.4 are the same as examples 9.1 and 9.2, but they're rewritten in prescription format, and that's using DA. So I won't work those out because it's the same workout. But if you prefer again to use the DA, you can see the examples that they have here in the book. Medications that are unstable in liquid form for extended periods of time are manufactured in a powder form that needs to be reconstituted before administration. Reconstitution is the process of dissolving the powdered medication, the solute, with the appropriate liquid diluent, the solvent. Following the reconstitution instructions on medication labels exactly to prepare them to the correct strength. Before use, the dry medication must be completely dissolved or suspended into liquid form. The most important step in reconstituting a powder is to read the label or package insert carefully because it provides the directions for reconstitution. The label states the total quantity of the drug in the container, the volume and type of diluent to use for reconstitution, and the final strength of the medication after reconstitution. The label also includes information on stability and storage needs after reconstitution. These directions must be read carefully and followed exactly each time a medication is reconstituted. Many oral liquid antibiotics are supplied in powdered form. Most are manufactured in bottles that are larger than the final medication volume to allow space for shaking before administration. Because the usual vehicle for reconstitution of oral medications is distilled water, graduates are used to measure the quantity of liquid to be added. The diluent should be added in increments according to the label, shaking after each addition. In some pharmacies, a computerized dispenser for distilled water is available. The label on every medication to be reconstituted provides the necessary information for the volume of diluent to be mixed with the powder to provide the desired dosage per unit of volume. When medication is supplied as a dry powder, the space occupied by the powder is known as powder volume. The powder actually displaces or takes the place of some of the medication needed to achieve the correct total volume. For example, a powdered medication for oral suspension may require only 78 milliliter of diluent to be added to produce a total of 100 ml of suspension. The powder takes the place of the other 22 ml. The total liquid volume of the medication will be that of the amount of powdered medication displacement plus the amount of added liquid. Product manufacturers have already calculated the powder volume or displacement value for medications, and the appropriate amount of diluent to add is listed on every bottle of medication. With medications supplied as reconstitutable powders, the manufacturer's container usually provides the volume needed for a normal course of therapy. For example, most oral antibiotic suspensions will provide enough medication for the necessary 7 to 10 day supply required. Sometimes a drug normally intended for pediatric use will be prescribed for an adult, and more than one bottle of the selected liquid medication may be needed to fill an entire prescription for the desired length of time. This will also be discussed more in Chapter 11. Before reconstitution, these medications are labeled with an expiration date from the manufacturer. Once the pharmacy reconstitutes the medication, the expiration date is no longer valid since these medications begin to degrade. The pharmacy must then assign a beyond use date or BUD according to the directions on the manufacturer's label regarding stability. The BUD should be clearly visible on the prescription label. So there's some examples of graduated cylinders. There is the cylinder showing 78 milliliters of diluent. Example 9.5, we're using this prescription label for erythromycin ethyl succinate for oral suspension, USP, which stands for United States Pharmacopoeia. 200 milligram of erythromycin activity per 5 ml reconstituted. So that means every 5 ml we give a patient, they receive 200 milligrams of the medication, and the total volume is 200 ml when mixed. According to the directions for preparation, the bottle of erythromycin will contain a total volume of 200 ml after reconstitution with 140 ml of distilled water. It must then be kept refrigerated and any unused portion discarded after 10 days. Expiration date of 3/2024 must be replaced with a BUD, a beyond use date, of 10 days from the time of reconstitution. The strength will be 200 milligrams per 5 ml. Now, the powder volume calculation. So this is already done here in this example. And of course, we can use um, a calculator for this as we can on the homework and quizzes and PTCB exams. So there's no real workout here, but the 200 ml that they're getting here in the powder volume calculation comes from the 200 ml when mixed. And then we are subtracting 140 ml, which we get that from the directions over here. Slowly add 140 ml of water and shake vigorously to make 200 ml suspension. store in refrigerator, and discard unused portion after 10 days. So that is where we're getting that 140 from because we're adding 140 ml of water. So this is here. This is here. And when we do the subtraction in our calculator, if we do 200 ml minus 140 ml, the powder volume is 60 ml. Remember that the final volume of medication in the container will always be greater than the amount of diluent added due to the powder volume. Thus, the total volume prepared should always be checked to ensure that there is an adequate amount for dispensing the prescription. If not, be sure the correct medication strength has been chosen and reconstituted as ordered. So example 9.6 uses a prescription label for us to answer the questions. So the first question is, what is the total volume of medication after reconstituted? So unlike the previous example where it said that in plain letters, it doesn't here, but the total volume, which the answer is here, 100 ml, is coming from here. That is the total volume after it is reconstituted. What diluent is indicated to be added to powder for reconstitution? Looking at our label, it's telling us we need to add water, which is where they got that from. What volume of diluent is added to the powder? And that is going to be that 61 ml. And then what is the powder volume? So we're taking the total volume of 100 ml and we're subtracting the 61 ml of diluent. So we're going to use our calculator to do that, and we would get that the powder volume is 39 ml. What special instructions are given for adding the diluent? So over on the side, it says prepare the solution at time of dispensing. Add to the bottle total of 61 milliliter of water in two portions, which is where they got the add water in two portions, and then shake well after each addition. And what is the metric strength of solution after reconstitution? And that is going to be over here, the 125 milligrams per 5 ml. So every 5 ml that the patient is taking, they are receiving 125 milligrams of penicillin V potassium, which is also equivalent to 200,000 units of that. Next question is, what is the medication strength in units? So that would be the 200,000 units per 5 ml. Same thing as 125 milligrams per 5 ml. What volume of medication is necessary to provide the 125 milligrams of medication? So just like I've said now 3 times, I think, in the last few seconds, 5 ml. So to get that 125 milligrams of medication, we need to provide the patient with 5 ml. And what volume of medication would be given for 62.5 milligrams? So this we would need to do a proportion using the strength of the medication on one side of a proportion. So 125 milligrams per 5 ml. Remember, we want to have the same on the top and the bottom for our units. We're looking for volume, so that's going to be our X, our milliliters, and our milligrams is 62.5. We will do 125x, and then that is equal to 5 times 62.5. We get out our calculator. and we do the multiplication side. So 5 times 62.5, which gives us 312.5. And then we still have 125x over here on this side. We want to get x alone, so we need to get rid of this 125, which is just leaving us with x. We have to do the same to this side. So we're taking out our calculator and doing 312.5 divided by 125, which gives us 2.5 ml. The same methods for calculation, ratio and proportion, and DA are used for oral, solid, and liquid dosing calculations. So just a side note, you're going to notice that pretty much all, like 90% of the math we do in the pharmacy is done this way. Liquid medications are dispensed using the measurements for liquids in the three systems, metric, household, and rarely apothecary. Conversions for the correct volume of medication depend on the measurement system to be used for administration. The household system is often used for home delivery of oral medications when a more accurate utensil for administration is not provided. The metric system is always used in inpatient settings. Reconstitution is necessary when a medication is unstable in a liquid form. Most oral antibiotic liquid medications come in powders that require reconstitution with a diluent. Distilled water, purified water, USP are the usual dilutants used. Follow the reconstitution directions printed on the medication label exactly to attain the correct strength. Liquid oral medications may be administered from a medicine cup, dose spoon, oral syringe, medicine dropper, or medication pacifier, depending on the volume of medication and the age and ability of the patient. Always provide an appropriate dosage delivery device when dispensing oral medications. As with all medications, the proper calculation and appropriate containers for administration are important for patient safety, which should always be the utmost concern.